I'm Dr. Pintu Kumar De, Associate Professor, JISU University, Department of Pharmaceutical Technology. Welcoming you all in the Industrial Pharmacy 1 practical class. Today our experiment will be preparation of standard cup of paracetamol. Now first of all you should know what is standard cup. The standard curve and what is the importance of standard curve. Standard curve we are preparing by plotting the concentration versus absorbance. Concentration, different known concentration solutions are prepared, and these are known solutions are plotted in on x-axis, and their corresponding absorbance, which we are taking in the UV visible spectrophotometer, their absorbance reading are plotted on y-axis. And if you see at this to a lower concentration up to a certain limit, there will be a proportional relationship between the concentration and absorbance. As the concentration is increasing, absorbance is also increasing proportionately. And as there is a proportional relationship up to a certain range, we can get a straight line. And this straight line is obtained for known concentration. Here we have plotted known concentration against their absorbance. Now this is called standard curve when we are plotting concentration versus absorbance of known concentration concentrated solution. Now this will be utilized for getting the concentration of unknown solution. Suppose we are having an unknown solution whose concentration is not known. You just take the reading of absorbance in the spectrophotometer and put that value. Suppose this absorbance value is this. Now you draw a straight line which will intersect this standard curve, and its corresponding. Gradually you go straight down, and it will intercept the concentration curve, and that will be the concentration of that unknown solution. So from the graph, manually you can calculate, or from the Excel, if you plot it in Excel in computer, then you get the straight line equation. From there is an option to get the straight line equation. Y equal to mx plus c. M is the slope of that curve, and y is the absorbance, and x is the concentration, and c is the intercept. Here intercept is 0, as I have drawn from 0. So the C is known, not known. When concentration is not known, that is on x-axis. And but y can be known. If you take the reading of unknown solution in the absorbance, can be known. So y value is known, x value is unknown, c value is 0. Then m value is also known, because from the standard curve of the known solution, we can get the m value, slope value. So everything is known, only x value is unknown. So if you put that y value in this equation, we will get the x value. So on the both way, from the manually, from the graph paper, from manual can be calculated, and then from Excel, from the straight line equation also we can calculate the concentration of unknown solution. Now, what are the chemicals required for doing this standard curve? We require this sodium hydroxide solution. This will be the media in which the paracetamol will be dissolved. First of all, we require we want to prepare 500 ml 0.1 in initially. This will be the media. This will be the solvent in which the standard curve will be prepared. Standard curve of paracetamol will be prepared. Now 500 ml for 500 ml 0.1 m in normal solution of sodium hydroxide, we have to calculate how much quantity of sodium hydroxide is required. We know that for 1000 ml 1N sodium hydroxide, the required quantity is 40 gram as the molecular weight or equivalent weight, and equivalent weight of the sodium hydroxide is 40 gram. So for 500 ml 0.1 N, we calculated here, it comes 2 gram. So if we dissolve 2 gram of sodium hydroxide in 500 ml, we will get 0.1 N sodium hydroxide solution. This is the calculation. From the basis, we have to calculate whatever amount we are preparing, whatever strength we are preparing. First, you have to write the basis. The basis is for 1000 ml 1 N, we require 40 gram. So any volume you require or any strength you want to prepare, that can be calculated from this basis. Next, prepare the stock solution. Stock solution of paracetamol. First, we are taking the pure paracetamol of 10 milligram. We are taking the weight in electronic balance, and we dissolve it in 100 ml of sodium hydroxide solution, 0.1 N, which we have already prepared. Now, what will be the concentration of stock solution? 10 milligram is present in 100 ml of solution. So 10 by 100, that means 0.1 milligram present per ml of stock solution. If you convert it into microgram, milligram will be multiplied by 1000. So it comes 100 microgram per ml. So the concentration of stock solution is 100 microgram per ml. Now from this stock solution, we will prepare different non-concentrated solution or different dilutions. So we are going to prepare standard dilute solution. Here we have taken 1, 2, 3, 4, 5, 6, 25 ml volumetric flask. 6 flasks we have taken. In the first flask, number 1 flask, we have taken 0.5 ml stock. We know that in 1 ml stock, 100 microgram drug is present. So in 0.5 ml stock, 0.5 ml contains 50 microgram of paracetamol. Ultimately, when you make up the volume with the media, taking this 0.5 ml stock, you are taking 0.5 ml stock plus 24.5 ml the media of 0.1 HCl. Now you make up the volume. So in the whole volume, only 50 microgram drug is present. So 50 microgram drug is present in 25 ml. So 50 by 25, that comes 2 microgram per ml. So its concentration will be 2 microgram per ml. Similarly, if you take 1 ml in the second volumetric flask, so it will contain in 1 ml, how much is there? 100 microgram. So 100 microgram present in 25 ml. So 100 by 25 means 4 microgram per ml. So concentration of the second diluted solution is 4 microgram per ml. Similarly, we are taking 1.5 ml, 2 ml stock, 2.5 ml stock, 3 ml stock. And if you are taking and diluting it with the media up to 25 ml, your concentration will come 6 microgram per ml, 8 microgram per ml, 10 microgram per ml, and 12 microgram. Now, in this way, we will prepare the media and the stock solution and the diluted solution. Now, we will see how to prepare the solutions, different solutions. So, we will go for preparing the solution. So, we are starting our experiment. So, before doing the experiment, I am showing you what are the apparatus we have taken for doing this experiment. First, here you can see this is the 500 ml 0.1 N NaOH solution. In this container, I have taken 500 ml of distilled water, and here 2 gram of sodium hydroxide is dissolved in this 500 ml water, and it is labeled as 0.1 N NaOH solution. Next is for preparing stock solution. This is the 100 ml volumetric flask. This is 100 ml volumetric flask. Here we will add the drug and we will make up the volume up to 100 ml. Previously, I have taken the weight of 10 milligram of paracetamol. You can see it here. Here it is 10 milligram of paracetamol is taken. I am pouring it into the funnel. Try to take the whole quantity just remove all the drug from the paper. Now I will make up the volume up to 100 ml. Then it will be a stock solution of the concentration of the stock solution will be 100 microgram per ml, as I am taking the 10 milligram drug in 100 ml. And next is I have taken 6 different leveled 1, 2, 3, 4, 5, 6. In this way I have leveled 6 25 ml of volumetric flask. In every all the volumetric flasks are marked, numbering given 1, 2, 3, 4, 5, 6. In this way I have marked it, and also concentration is written on the flask, that this concentration will be 2 microgram per ml, this will be 4 microgram per ml. So everything is kept ready on the table. Here you can see everything, all are there. 6 volumetric flasks, stock solution, and the media. So now I will be showing you the dilution, how we can dilute. So this is the stock solution, from where I have pipetted 5 ml. I have taken 5 ml pipette. First I have pipetted more than the zero level. The level is withdrawn. Now I am adjusting at 0. The lower meniscus is adjusted at 0 level, 0 marking. Lower meniscus will be adjusted at 0, and now it comes 0. So I am taking the first number 1 25 ml volumetric flask, and I will be taking 0.5 ml, 0.5 ml. From 0 to 0.5 ml I am taking. It should be controlled properly, so that it will not add 1 drop extra also. Just I am stopping at that marking 0.5. I don't know you can see it or not. So this is 0 to 0.5 I have taken. Again I will draw more liquid. Again I will adjust at 0. Then again you have to take from 0 to 1 ml. In the next volumetric flask I have to take from 0 to 1 ml. Again I am drawing some more liquid. I have to adjust at 0. So more than 0 I have drawn, and then adjusted at 0. Okay, it has been adjusted 0. Now I am taking the second one. I am taking 1 ml up to 0 to 1 ml. 0 to 1 ml. I have to stop at 1. Okay. Again I will be taking in this way. I will take 1.5 ml, 2 ml, 2.5 ml, and finally in the number 6, 3 ml. So in this way I will be taking the stock solution, and then I will add to every volumetric flask. I will add this media and make up the volume up to 25. Okay. Okay. First let me make up the volume, then I will come back. I'm making up the volume. Volume is being made up by up to the mark, with the help of more water, more media, and done in any way. Very accurately, very carefully you have to do, so that extra liquid is not coming. This way, all the for all the 6 containers, so all the 6 volumetric flasks, I have to make up the final volume. Then I will be taking the reading in the spectrophotometer. First, I have to make up the volume. Then this way, make up the volume. Volume is made up. Now, we will be taking the spectrophotometer and how to handle the spectrophotometer. Then I will be showing you the next. I will be showing you the spectrophotometer. Here you can see the spectrophotometer. You can see it. You two cuvettes. Two cuvettes are there. There are two cuvettes. Here in one cuvette, in both initially in both the cuvette, will take the media. Media means 0.1 N HCl. So I have taken 0.1 N HCl, and there are two cuvette holder. There we will keep it in this way so that light can pass. The transparent way, the transparent portion will face towards the light source so that light can pass through the solution. I am taking two cuvettes. In both the cuvettes, I am taking the blank media. This will be the blank, and placing in the cuvette holder, and we will close this and will run spectrum mode, baseline correction. Baseline correction first will do so that the light will pass within this range, the scanning range of 200 nanometer to 400 nanometer, and within this range the light will pass and it will scan the solution so that in this media there will be no absorbance. Media will have no absorbance. Now we will put the solution to take the absorbance in this cuvette. In one cuvette, the blank will be there, and that another cuvette will place the sample and we will take the reading of absorbance. So before taking absorbance, scanning is baseline correction is over. Baseline correction is done so that absorbance will be nullified if there is any for media. So media have no absorbance now. Now I am putting this solution number. This is solution number. For scanning, I am taking any one solution we can take. This is solution number 4 we can take for scanning. So scanning is done. We check the lambda max of the drug. Lambda max gives you the identification also. First we will test whether the paracetamol which is taken, that is actually paracetamol or not. How can you understand? If you scan within this range, UV range or visible range, and it will give you the absorbance maxima at a particular wavelength, and that is the characteristics for a particular drug. And from the absorbance maxima, you can identify the drug also. So here I put the sample in the sample holder, and now I start scanning. For starting the scanning within this range, 200 to 400 nanometer, you have to press the start button. Now, as I press the start button, it will scan how instrument is scanning. If it is possible, I could show you here. We will show it
you see it, the screen. Here you can see the screen of spectrum. Scanning is started, and now you could see the how scanning is going on, and it will give the lambda max. Slowly that graph is going upward. You can see it from here. Slowly graph is going upward, and that means x-axis it is lambda wavelength, and in y-axis it gives absorbance. So slowly it is going up, and then at the maxima peak will be obtained. Now it is going downwards. That means at that point the maximum absorbance is getting at the peak. That will be the lambda max. So how could you estimate that lambda max? Here from the data processing we can get it. I'll show you. Let me do the data processing. Here you can see the data processing button. So I'm pressing it, and 3. If you press 3, you can see the peak. Here you can see the maximum absorbance come at 257.6 nanometer. These are the absorbance value. These are the wavelength. Absorbance value is maximum here. 0.692 is the absorbance maximum absorbance value, and that the corresponding lambda is 257.5. So lambda max will be 257.5. You can check it from the standard book that the lambda max of the paracetamol is near about that 260 to 257, like that. So now the lambda max checking is done. It's over. Now I'm setting the lambda at that value. 257.6. Now I'm going back. I'll be putting the wavelength. Now I'll record the absorbance. For this solution here, you can see this. I put the lambda max 257.6, and the absorbance reading is coming 0.627. This will be the absorbance for this solution number 5. So for other solutions, directly if I put in the sample holder, coming first I have to record it. Coming 0.627. And another sample if I place, you can easily see the absorbance reading is out changing, and it will be corresponding to its concentration. This way we will get the absorbance value, and then as absorbance will be plotted against the concentration. We will get the standard. Okay. So here for another solution it was 0.697, and for this solution here you can see it is 0.555. So this is another solution. Solution number, you can record solution number I think 3. Solution number 3. For 3 it is 0.455. And for similarly for other solution also I am taking the. In this way we took the reading of all 6 samples. Now the concentration of each and every solution is known, and the absorbance is also obtained from the spectrophotometer. We will plot the concentration on x-axis and the absorbance on y-axis. And if you connect the line, if you draw a straight line, you will get the standard graph. From there, if you plot it in Excel, you will get the equation for straight line. From there, you can get the unknown solution absorbance, and you can directly calculate the concentration or manually from the graph also by extrapolating the absorbance to the concentration line, you can get it. Thank you for watching this experiment. Thank you very much.